This ellipse is a little bit different than the ones we talked about yesterday for the mere fact that its center is no longer at 0, 0. Okay? The center of any ellipse is simply, it's kind of like the center of any circle. If I take two diameters and intersect them for a circle, and don't I find the center? Okay, so ellipses don't have diameters. Ellipses have a major and minor axes, right? Okay, because they're different lengths, so we can't call them diameters. But the intersection of the major and minor axes are going to provide you the location of the center. Does that make sense? And we need the location of the center to construct the correct equation for an ellipse. Okay. Yesterday we talked about the ellipse being, x squared over some arbitrary a value squared. And we'll talk about how we get that value here in a moment from the picture. Plus then y squared over b squared is then equal to 1, right? Okay. Now if I had a ellipse centered at 0, 0, you could write it this way. X minus 0 squared over a squared plus y squared y minus 0 squared over b squared equals 1, right? Okay. Place big box here. All right, so we have that. Does that say the exact same thing as the above statement says? Does x minus 0 squared say the same thing as x squared? Yeah, so if I wanted to, I could write any ellipse that has a center at 0, 0. I could write like that bottom equation. Okay? Doesn't make a whole lot of sense, but my hope is that you recognize that when the center moves from 0, 0, you can use the exact same format. Okay? So when I move away from 0, 0, let's say I move in the x direction, just try to stay consistent with what we've talked about with circles. Maybe I move a distance of h in the x direction, and then I move a distance of k in the y direction. And now I have the generic formula for any ellipse, regardless of where the center is, knowing that the center's location as an ordered pair is h comma k. And that should make sense in regards to transformations. Whenever I subtract an amount from a variable, and it doesn't matter the variable, we've dealt mostly with x's so far because we've done transformations predominantly with functions. This is not a function, okay? It fails the vertical line test, right? So with functions, we usually just subtract it from x and then knew, well, that moves it left and right, correct? Well, if I subtract from y before I run any other function, before I do any operations like squaring it, if I do that subtraction here from the y, that's going to move it up and down, but it's going to move it up and down kind of in the reverse order that you think. So if I'm going to move it up 2 units, it would be y minus 2. Does that make sense? If I'm going to move it up 5 units, it would be y minus 5. If I move it down 6 units, it would be y plus 6. Is that okay with everybody? Okay. So, and it's the same thing that we talked about with transformations for your x variable. Before you run an operation on it and you do subtraction, it's going to move it kind of counterintuitive to the direction that you think it would. Okay? If it's plus, it's going to move it left. If it's minus, it's going to move it right. Okay? And then for the y direction, if it's minus, it's going to move it up. If it's plus, it's going to move it down. Okay? So, how can we use that information to come up with the equation of this ellipse? Okay? First thing you're going to need to do, because the picture on your exam is going to look just like this. Okay? Maybe not just like this, but very similar to this. You're going to want to find where the center is. Where do you think here that the center is? 5, 2. Okay? The way to visually do that is take what you think to be your major axes and what you think to be maybe your minor axes, and you see where they cross. And they cross at 5, 2. All right, so h and k are now 5 and 2. So now just auto-filling into this formula, I'm going to have x minus 5 squared I'm not going to worry about the denominator yet. Plus then y minus 2 squared is then equal to 1. Now we got to come up with our denominators, right? So we're kind of working backwards from the example that we did yesterday. We need to find, basically these denominators are telling you the length of your axes. Okay? If I can, and it doesn't really matter either that distance there or that distance there, they should be the same. Okay? I'm looking, and that's going to tell me, that A value or maybe the B value that needs to go in that equation. What is, if I look at maybe just one of those distances, what would that length be? 5, right? Okay. The entire, a lot of times maybe, if you go back through some of the PowerPoint, it calls the length of your major axes, it calls it 2A. Okay, because if that's A and that's A, is it the total length 2A? All right, so you can do this one of two ways. You say, well, I know that the major axis is 10 units long, and then half that would be 5. Okay, and so my A is 5, but what do we want in the bottom? A squared. So what do we got to put down there? 25. Okay. Now, like I said, I don't really care whether I call that A or I call that B. I know that's the horizontal axes, right? So the horizontal axes needs to be paired up with the x variable. Okay, horizontal and x always go together, right? Okay. I then need to find the denominator that goes with the basically the vertical axis here. Okay. So what would, maybe in our PowerPoint they call that 2b, but we only need really b, don't we? So how long would that 2b end up being? So we go from 5 to -1. That's 6 units, right? So 1b would be 3 units. But what do I need to do with that 3? Square. So then I get 9. And that then is the equation for that ellipse. Is that all right? Okay. Now I want to talk briefly about, maybe I want to find the location of the foci. Okay. So let's do that. Which axes do these things? When I want to find a focus, which axis do they show up on? They show up on the major axis. So they're going to be on my horizontal axis somewhere. And if you remember from yesterday, the formula looks like that. Okay? And again, I don't care. This is the key thing to remember. You don't care what a squared and b squared are. They don't. The way we're approaching this, I don't know if a is a 25, and I don't know if b is the 9 or vice versa. Because I don't care. I just know that when I'm finding C, what I'm doing is I'm trying to find the length from the center to a focus. Okay? That's what C stands for. All right? The length from your center to your focus. And if I'm trying to find that, it has to be what kind of number? Positive. Okay? So that tells me then if I'm finding a distance, it has to be positive. Does that tell me the order that I got to subtract these? I have to go 25 minus 9, don't I? Okay. So then C is going to equal Huh? Or we'll go 16.
Okay, I apologize. I can't subtract.
That's all right. So then root 16 is 4, right? Okay. Now, we got to pay attention to what that means. The C distance is the length that you travel from your center to a focus. Okay? Well, if my center right now is located here at 5, 2, then I need to move a distance of 4 units away from that to find a focus. So I'm going to go find a focus right there at 9.2, call it F1. And I'm going to go this way, and I'll find a focus here at 1.2. Call that F2. Is that doable? Okay. If you were to mess up your formula, let's say that because of what we learned today, we learned a formula that's c squared equals a squared plus b squared with another kind section. If I were to add 25 and 9, I'd get 34, okay? And square root of 34 is a little bit less than 6, right? Bigger than 5, but less than 6. Well, if I move, let's say it's 5.5. If I move 5.5 away from my center, puts my focus out here, doesn't it? Can my focus be on the outside of my ellipse? No. Okay. So kind of the physical relationship between points that help create the ellipse and understand where they should be can maybe help me understand the relationships of formulas and realize which formulas I need to use inside certain kind of sections. Does that make sense? Okay. Please be able to do that. If you've got questions on that stuff, don't hesitate to ask. But that is very similar to a question that you're going to see next week.